national anthem, please. Thank you. Thank you. Okay, well, as you know, most of our CTBUH seminars we like to start on time, and we do know that we have Mumbai traffic problems, and so we will be expecting more and more people during the course of the seminar. I'm Anil Hira, Deputy Chairman of CTBUH India. I'd like to welcome you all here. It's going to be a very exciting topic. It's a topic that's a bit of a passion for a lot of people here. It's an important topic. But before we start the actual seminar, I'd like to call upon Girish Chavi. As you know, he's the CTBUH Chairman for CTBUH India, and he's going to tell us a little bit about CTBUH and recent activities. Thank you, Girish.
Thank you, Anil. Good evening, everyone. I'm back on this podium after 15 days. And it's my job every time to tell something about CTBUH, and now it's by heart. I mean, they have done that so many times, but for people who have come here for the first time, it's important for me to tell what CTBUH is all about. So, CTBUH is the Council on Tall Buildings and Urban Habitat. So it's not only tall buildings, but it's for the people who live in urban areas and to address their, sort of various problems and concerns and all those sort of things. And of course, living in tall building is a major part of living in urban areas. You go anywhere in India, India is growing tall. So our aim in forming CTBUH India 8 years ago was to jump at a stage when we don't have to invent something to address these tall building and urban habitat issues, but by way of collaborating with experts all over the world and get the ready-made knowledge back in India, use it, and advance, leapfrog. That was the idea. And we have been quite successful in doing that. We have created awareness among many, all the people connected with tall building industry, and our developers, architects, engineers, all consultants. They have benefited a lot by these interactions with international collaborators. So, CTBUH is basically disseminating knowledge by way of conferences, meetings, publications, research, competitions, seminars like these. And world over, these programs are continuously going on. Even in India, I must say, we hold about 8 to 10 events per year, and that involves all types of professionals, students, lay people, all sort of people we gather and make them aware about how to live in tall buildings and urban areas. That's our aim. Now, when we say all aspects, you think of any discipline that, fire is a major hazard in tall buildings. Elevators, without which tall buildings cannot be built. Civil engineering, structural engineering, construction management, construction engineering, architecture, the bylaws, all such things, facade, everything that you name which is connected with urban development and tall buildings we tackle. Being interdisciplinary, like this particular program is for structural engineers, so maybe next structural program may come after 2 years, but in between we tackle each and every discipline. Various people come here and discuss various aspects. Our CTBUH holds international conferences, as I said, and every year there is one international conference in a different city every time. This year it is in Singapore, and we have traveled most of the big cities in the world. CTBUH headquarters in Chicago. Last conference was in Chicago. Before that it was in Dubai, I suppose, in Shanghai, all Germany was another conference. In India we held one conference in 2010 and it was a grand hit, and that was the first time I got introduced to CTBUH India and got involved. Then we also engage students in CTBUH activities. We go to colleges, our members, we enlist professionals to go to colleges, deliver lectures, hold competitions, hold workshops, and engage students in our activities. And I think about 2 to 3 events per year we dedicate to students. I must tell you one thing, all our programs are free for the audience, and we conduct our programs with the help of sponsors like Adani Cement is our anchor sponsor this time, and pristine commercials, and we don't charge fees for the audience to attend our seminars. They are by invitation, and so sometimes we have to make sure that the right people come for our events, and this is a structural engineering, concrete related program, so we call relevant people for such programs. So in case if someone has inadvertently by mistake registered for this program and finds that, oh, this is not a program for me, I'm sorry for that, but we make sure that we send these personalized invitations to only relevant people for the topic. So just make sure that you use the registration for yourself and don't circulate it to people who are not invited. And of course, these are sponsored events. We have limitations on seats, we have limitations on food, so we really discourage people who are not registered and who are not relevant, not invited for that particular thematic event. I'm sorry about this, but I have to tell you all this. This is the active executive committee for CTBUH India, and all these people are well-established professionals, very senior people, and although they are very busy in their own businesses, they volunteer their time and resources for CTBUH activities. And I am really grateful, thankful to all of these people. Then there is a core team which actually executes these programs. Once a policy or strategy is decided for a year, this is the group of core group and the volunteers who dedicate their time, again without expectation of any remuneration or any return, and they fully devote their time to such events. And there is a large group of people, professionals, who actively support us by way of their, monetarily as well as their own time. We rope them in to go to colleges or other events to deliver lectures, and they do it again out of their own interest. So this is a very large active group of people and volunteers. And if anyone wants to support this cause, you are welcome. You just contact our core group team and you will be roped in. And we can request you to contribute to our ventures. Since 2015, as I said, we have conducted many events, and if you are not aware because you belong to a particular discipline, but almost every 2 or 3 months there is a event that CTBUH India holds. Some of the events are so popular, like walk. We have a CTBUH walk every year, which goes through various precincts of our city, telling people what is a tall building, how it means to construct a tall building, then the comparison between the old city and the new city. All such thematic walks we conduct, and there is a world record. CTBUH India gets maximum participants in all the walks. I mean, these walks are held in all the cities of the world. There are 40 chapters worldwide. CTBUH is 40 country chapters or city chapters, and there these walks are held. And CTBUH India holds the record of maximum participation for last so many years. So it's a scene to be watched, and very well organized, very well curated walks those are. And many of our supporters, like Lodha is sitting here, they support us in conducting these events. Then we have also collaborated with like-minded organizations like IDAC, FSAI, IGBC, and other organizations, ISHRE, and we conduct joint events for the benefit of the members of these organizations. So we go like this, and so many events. Even in COVID time, we were not behind in conducting online events like interviews with legends and panel discussions and all those things. And also on social front, our CTBUH team was in the forefront of distributing khichdi to construction workers of many sites who were stranded in Mumbai in those days. So this is the walk. I mean, you can see the support we get every time. And so we come to these events. This particular event we are talking of, Anil will be curating this event, and this is particularly keeping in mind the sustainability campaign that Government of India has come up with. I think by 2070 there is an objective of net zero carbon in construction industry, and we, the CTBUH India, wants to contribute to this campaign, and this is the first such event that we are holding to make people aware what it is that we'll see as we go on. We have also, now this is an achievement that I want to highlight. CTBUH India core group and some supporters, professionals, they guided a students team, and it was selected as was it top 25? Yeah, top 25 semi-finalists in CTBUH International Students Competition. So that was one achievement that I can. And these are our other members who are on CTBUH international committees, and they also represent our concerns in those international meetings and all that. So this year the conference is in Singapore, humanizing high density. I'm really sorry the link for registration is over. I mean, there is no more seat available, but till the last event I was advocating, go there on the portal and register yourself. That is no more available. All seats are full, but this is the conference this year. And focus was another something that we entered into with an MOU. And DY Patil, an educational institute, we have an MOU with them to do events with students. Our next event in this series will be on elevators, and that's on 1st of December. Again, I'm telling you, if you are relevant to this topic, you will get an invite, and then we'll see again on 1st of December. And then there is a very interesting topic which really concerns the urban habitat, is sustainable transit-oriented, transit and tall future of cities. So you are witnessing this kind of development. We are getting new metro lines and new developments are springing up. And I must say that Mumbai has witnessed this transit-oriented development since ages. I mean, you must remember, wherever there was a local station, local train station, the shopping centers and markets and those things, they evolved there. So we are not new to this, but in the context of the recent development, the boom in construction industry and tall buildings, this will be a very interesting topic to attend, and this will be in January. So look forward to these events as well. So thank you very much, and look forward to an exciting and knowledgeable session.
Thank you, Girish, for the introduction. And just to elaborate, the Singapore conference, I think there's quite a large representation from India. So that's going to be very encouraging. And I'm going to be there, and I can see Sandeep. He's going to be there, but I know there's a few candidates. So I just want to give a 5 to 10 minute introduction and put the whole topic in context in terms of the global context. A 5 minute introduction, and then we get into the real business with our experts. So it's like, I can't operate these computers. Okay, thank you. Thanks a lot. Okay, so the topic, zero carbon ambitions in high-rise buildings. It's a very ambitious topic, but it has to be done because we do need high-rise, and we do need to get into zero ambitions. Now, how does this work? Apologies. So, I've been doing a bit of reading, and you talk to astronauts, and when they get back, some of them get depressed, and you wonder why, because they see the Earth as one. No political barriers, no cultural barriers, there's just one Earth with a very thin atmosphere that protects that Earth. And they come back and they see the wars, and they see the conflicts, they see the politicians, and they get very disillusioned. And that's the reason why they get depressed. And we wonder why, after experiencing such a dramatic event, why do they go through depression? And I've read a few books of some of the astronauts and their biography, and we are one. And sustainability in this carbon emission problem, it's a global problem. What we do here affects my country in Australia, what we do in Australia affects India. And we need to understand that, we need to appreciate that. And it's happening. Right? I've been around a couple of generations now, a few of us a couple of generations, a few of them one generation. But in my generation, I've experienced some things. I come from a very cold town in New Zealand, and my father was a milkman, and I used to early morning deliver milk, and it was freezing. That same town now, they don't complain about, we don't have frost, it's quite mild temperatures. I go to South Island and studied in Christchurch and went to Franz Joseph Glacier. That's this one, bottom left. And in the past 100 years, you'll see the difference in terms of the retreat of the glaciers. And then I went there just recently, since I started, when I was at university, to where it is now, there's been a movement of 1 kilometre just in 20, 30 years. So there is something happening. So all these politicians that talk about a particular topic to say, look, it's not a problem, there's a lot of rubbish. It's happening. Temperatures have increased and it is happening. I've been very, very lucky in the last 1 year. I've visited these are not postcard images, they're from my telephone. Beautiful. And most of these places, it's untouched. But unfortunately, what's happening is going to have an impact on these sceneries. And I'm the lucky generation. Maybe another generation is going to be lucky. I'm not too sure about what's going to happen in the next few generations. At top left hand, where the First Nation people of Australia, they've lived there for 60,000 years, 2,000 generations, but they know how to work with the environment. We, the more modern generation of the cultures of the last few thousand years, well, we didn't quite know how to work with our earth. And we now need to deal with it because the problem's escalating. So, life, us, we may be able to adapt to the 2 degrees global warming, but Antarctica will not deal with it. Right, that's the problem. And when we talk about Antarctica, the size of probably 1.5 times bigger than the US in the area, that's massive, and it will start melting. We're only touching on it. There's evidence, just like photography, that it's retreating, but the impact has only been about 1%, or less than a fraction of 1%. But that's escalating, and unfortunately, the seawater level will rise as the Antarctica melts, and Antarctica is shrinking, and we've got a problem. We do need to reverse that. So what is this climate emergency? What is it all about? Well, if you look at that, what's happening is that we expect the temperature to rise by 2 degrees. And that's going to be catastrophic. Right? For the last 50 years, I think 40, 50 years, to today, from the turn of the century, the 19th century, 20th century, the temperature has gone up by 1 degree. And we expect in the next 20 years, 30 years, another ½ degree. Then we need to reverse it. It cannot go much higher than 1.5 degrees, otherwise we've got a problem. And so if you look at the next graph, this is what's been happening. And so in my lifetime, somewhere in 1955 to now, you can see the damage that I have done to the Earth, which is going from 1955 to 2020. That's a lot of damage compared with the previous 200 or 300 years of the previous 2,000 years. The next 50 years is critical. We do need to reverse it in the next 20, 30, 40 years. And why do we have to deal with it? Because we are the problem. Right? The greenhouse emissions, buildings account for 28% of the emissions. but the construction industry is a big contributor. In fact, construction industry is responsible for 40% of the global total emissions. And when you think about it, after water, concrete is the second biggest widely used substance in the world. Concrete. And when you combine that with steel with 8%, we are a big contributor. But look, we shouldn't get disillusioned with it. We're not the problem. We do need to build because we need to accommodate urbanisation, and we need to improve our lifestyles, and that's a challenge. Urbanisation cannot stop that. In fact, it's a good thing. We just need to be more efficient at what we're doing, right? And understand that construction is a big contributor, and we now become important. And I'm not too sure whether we're doing the right thing. We worry, everyone has different interest groups within our industry. The architects will have their creative interests, the structural engineers, you know, they're going to do more and more to, instead of refining, we tend to get confused on what to focus on, and we forget the basics, just to come up with efficient structures, as opposed to making them oversafe. And we need to start addressing all that. We need to focus on quantity. And so we are not the culprits. We need to deal with this, but we're becoming very, very important, and we need to work as a team. So that's the issue, that's the challenge. I know a solution that doesn't involve construction. One of the solutions is that if every human becomes a vegetarian, we do not have a global warming problem. So please don't convert to a vegetarian today, because we will run out of food in the vegetarian sector. But have a think of its food for thought. That if the world becomes vegetarian and we build efficient buildings, we do not have a global warming problem. Okay. So what I want to do is that, because we want to run this show efficiently, I'd like to do a brief introduction to the speakers now, and then I'll just call each speaker up to do their presentations. We've got 4 fantastic speakers. They come from a real wide range. And I'm not going to read anything, I'm just going to say a few sentences. The first speaker is Raj Patel, and I know Raj, fortunately. It's been a pleasure working with Raj, and in particular their company, Gensler, who are the largest architectural practice in the world. I've had the privilege of actually going to their head office, one of their head offices in Los Angeles on a project, and it's a spectacular office. It really is a spectacular. I think it's one of the places that any one of you guys go to Los Angeles, try to go and see their office. I loved it. And the coffee was very good there too. But Raj, he's a partner with Gensler, and he's one of the heads in the Middle East, and I think he is doing a little bit of work in India as well. He's a very passionate designer, and I think it's going to be quite interesting listening to Raj. So thanks, Raj, and thanks for coming all the way to Mumbai to present. Abhijit Kulkarni, he is here. Abhijit, well, I sort of work with him too. I know him as well because he took over my job in Mumbai. And Abhijit, well, he's a great structural engineer. He's going to talk with respect to engineering. And Abhijit is based in Mumbai. He spent a lot of his career in doing tall buildings in the Middle East area. In fact, he spent most of his life in the Middle East, or working life, even though he originates from Mumbai. So welcome, Abhijit. Abdullah, thank you very much for coming. He's the head of sustainability with LODA, and we know that LODA is doing a lot of work, and I'm really looking forward to listening to Warren, because we have developers who are constructing buildings, As I said, construction is the biggest contributor, and I know that all the respectable developers now are looking to sustainability, and hence they have sustainability departments, and hence LODA has a huge of several people in the sustainability department, and just even internationally, the construction industry is taking sustainability seriously, and look forward to hearing from you. And I think that's a big theme in the Singapore conference. And Mr. Vijay Kulkarni, concrete technologist, and I really look forward to listening to Vijay because in Australia, concrete technology is very, very hot topic. And the good thing is that there's even talk of a zero carbon concrete. Maybe when we have a coffee, I'll look forward to talking to you about that. But we as humans and as engineers, we do try to deal with challenges, and concrete is the biggest contributor to carbon emissions. And we're already starting to develop at research level zero carbon concrete, so we can build whatever we want without any emission. And what an objective. And I know there's a lot of interest on concrete technology, international concrete technologists coming to India, because there's an opportunity for India where we've got 1.5 billion people. There's a huge opportunity to leapfrog and build buildings with concrete with zero carbon. So it's going to be a really exciting seminar. And so without further more to do, I'd like to invite Raj onto the podium. And Raj, we look forward to your presentation.
Okay, hi, thank you very much. Many thanks for inviting me here. It's always a pleasure to come. I only apologize that I'm an architect, and I know a lot of people have issues with that. I think the best thing of my profession is how to think slightly differently to help us come up with solutions. And so if I can just touch anything for all of you, just something that might make you think a little differently, I will feel I have achieved something today. So. Anil explained, mentioned already, but our firm it's almost 55 years old. We have about 7,000, 6,000 professionals. Unfortunately, we don't have any engineers, so I apologize for that as well. Though we are the #1 ranked design firm in the world, we work on just tons of projects. I think we cover and we design 1 billion square feet of space every year. So we are in 53 offices throughout the world. We've got 3,300 currently active clients, and as I said, about 6,500 professionals. And in our region, we're broken up into 10 regions. It's the only way a huge firm can organize themselves. So our region, which is Middle East and Asia Pacific, has about 9 offices. We've got about 370 people. I'm based in Abu Dhabi, and I lead the architecture practice in the Middle East. Of course, India now is becoming a great opportunity for us, great work that's happening over here, so I'm getting more and more involved over here. But I think we're in what is going to be a great region going forward, because there's tremendous growth here, especially with certain slowdowns that we see in the West. Just a little bit about me. Obviously you can tell I've been brought up in the US. I have an undergrad from the University of Cincinnati in architecture. I did my master's at Yale. I'm a registered architect, and have been in the Middle East now for 23 years, and have been very, very fortunate. I got about $6 billion worth of projects built. So it's a lot of fun for any architects that are out there. It's really the best thing in the world to see your projects go up. But you just have to remember, for every one that goes up, you're gonna have to deal with 10 of them that don't go up. And that's where it really is important to keep focused on what is important in design. I've always been influenced from a very young age, I guess, in high-rise buildings. I actually worked in Mumbai as an internship for Charles Korea many, many years ago, and you can tell even back then the fascination as we go tall. How do we deal with the environment, whether it's wind, whether it's form? It's always been there. And then after my undergrad, I worked at Perkins & Will, and of course Rob Johnson has left his mark also here in Mumbai, again pushing the ideas of sustainability and design in different ways. Now, how do we basically bring maybe the environment and parks and greenery into buildings? And then after I finished Yale, I worked for Adrian at SOM, and then it just went to the next level. So how do these high-rise buildings, and architects have always been infatuated with going tall. So it's been great for me going through this process of working with people like this, and it's always sort of inspired me. But I have to admit, Anil, when I was sort of asked to come and make this presentation, which is not a very simple one at all, when you're doing high-rise buildings, it really leads sort of to the question that, you know, there's a big elephant in the room here that we need to talk about, and it's the elephant. I mean, these things are massive. Skyscrapers are massive. They don't really make sense when we're trying to achieve some of the objectives that we have. And we have to kind of understand that. In fact, if you take about 100,000 of these, you can basically construct a gorge. And it's very interesting. There's about 400,000 elephants in the world. So about the equivalent of 4 of these things. I mean, that's the kind of weight that it takes. And the problem really is high-rise in general is just not very sustainable. And plenty of studies will show that mid-rise, low-rise is a much better way, especially when we start talking about how to improve carbon reductions. Going vertically doesn't always make the most sense. We're getting better and better at it, but it's important to understand these. So it also leads to the question, why do we go tall? And I think there's plenty of reasons why we do that. There's plenty of explanations why we do that. Not all of it is money, I would say. For most of you who don't know, the Burj Khalifa actually is a money-losing proposition, but they've made their money with the real estate that's been sold around it. So again, you could say money is involved, but we have to think that we do these for many, many reasons. And skyscrapers are not going to die, and it's a infatuation of every architect. But it's important to go through and understand these. This is a wonderful graphic. I really sort of love if you look and see the history of development. You can kind of call it into 3 stages. And that first one is what I would say soil. We lived in caves, we lived underground, we lived in things that the earth offered. And the only material there was really soil, and that's all you had to deal with. This next stage is where we started going taller, and the material we primarily used for this was stone. And the issue with stone is that at some point it becomes a limit, and you can't go above that. And then you get into this stage where we are right now, and to do what we're doing now, it's steel. So we do need to think about materials as we go forward. I don't know what that other material is going to be, but I would bet a lot of money. It won't be in my generation. There will be another material that will help replace steel, because steel and concrete are just almost old school, in my opinion, of what ambitions that we have. The other thing I'll say about skyscrapers is it's no different. We don't live in a different period than, say, the Renaissance. Every family, every city throughout Europe built cathedrals slightly taller than their neighbors. This is just a human desire we have. We all want to be the tallest, we all want to be the best. that is never going to go away. But it's important to understand the evolution of why we get there. So what we need to do is just maybe think a little differently, and just going back to this guy, and nothing against animals here, it's just a metaphor, but this is a pretty big animal. And what we're thinking about is how do you get lean and mean? How do you get from something that's about 5,000 kgs to an average cheetah, which weighs about 64 kgs? It's pretty phenomenal. And so this was just a little fun, because with AI we can do this now. And so we need to think about what is this new thing that we're going to create if we want to go incredibly tall. We need to think differently, because it is about efficiency. It is about getting lean and mean. If we're making buildings, we can't think of elephants. We have to start thinking really thin and elegant, and this is one of the ways we're going to save resources. So at Gensler, a few years ago, we made a pledge, which we call GC3. It's our Gensler City's Climate Challenge, and it's basically to say by 2030, all of our work is basically going to achieve carbon neutrality. Now, I don't know how we're going to get there, I'll be very honest with you, but it's a pledge we've made because somebody's got to do it, and we got to start somewhere. And so every day, throughout the organization, throughout our different communities, we're trying to find ways how to get closer and closer to achieving this. I know you brought up this point, but 49%, these are stats in the US, are basically what happens when we make buildings. And it's the embodied carbon when we actually make the buildings. And of course, there's an impact, a huge impact when we use the buildings and the efficiencies, the operational carbon. And while the operational carbon is getting more and more efficient, we're also seeing that building materials and embodied carbon reductions is also getting more and more efficient. So I think once we focus on things like this, we will see that there will be outcomes of how to get this 49% to be reduced. This is just a very simple graphic showing that the embodied carbon, see, this is stuff people didn't worry about years ago. You wanted to design something sustainable, but you don't realize that the material that you're bringing in has a carbon footprint. There's an embodied carbon to it. So you might create something that's beautiful and the wind goes through it and you don't need AC, but we were never measuring what are we building in order to achieve that. And so that's why embodied carbon now it's really something we need to think about, because it's what we need to extract, to manufacture, to transport, and to install something on site. And it's got a huge impact. Operations, we're not going to get into operational carbon. I think everybody understands that as well. And then carbon offsets. So it's really about this. As designers, we can make our greatest impact on really focusing on this. And I'll give you some examples of things that we're doing. And then the operational carbon, as I said, everybody knows this is as important, if not more important, because you can see just by the numbers, that's where a lot of our energy is going right now. So I thought I would just talk about some strategies as best as we can as architects of what we can do. Some of these seem incredibly simple, but I don't see them being implemented, so it's always a good reminder to everybody, I think. So orientation, form, and shape, facade design and optimization, reduce areas for basements, design for flexibility and material selection. And I'd like to show some examples and talk about each one of these a little bit. The Shanghai Tower, which we designed, was optimally shaped and positioned so that we reduced 24% of the wind loading, which means 24% reduction on some of the steel and the structure. That's say $58 million. So when we fall in love with forms, especially as we go tall, Burj Khalifa has done the same thing. You have to do a lot of studies and a lot of wind analysis. And for developers who are out there, I would say don't fall in love with things without understanding the ramifications of what they are. There's still ways of achieving what you want, but it's really important in high-rise buildings that shape and form is super important. This is just a very simple graphic showing the shape of 6 different plates. Each one of these plates is 1,000 square meters. Now, what function each one of these plates can support, that's what architects do, that's what interior designers do. But each one of these shapes represents 1,000 square meters. And for most people, that would seem like, okay, so I can just pick whichever one I want. But the reality is, you really can't, because each one of these has a different surface area. Now, this is just a 4-meter tall facade around each one of these shapes. So you can see all this extra area is material. And how do we get that material? We're probably going to be digging in the earth and getting something. We're going to be fabricating something. And so shape and form really do matter. When we fall in love with certain shapes, we should also understand their impact on the environment and the materials and the design. This is just surface area. Of course, depending on what systems we pick, we have a substructure system that supports those materials. And so keep in mind that form, shape, areas all contribute to basically stuff. The elephant, it's stuff. And we're trying to think about how do we get lean? How do we reduce these? Because that is sort of what we do in terms of efficiency. Facade design and optimization, I've been fascinated ever since moving to the Middle East on facades. It's one of my passions. I just love designing facades. And I want to show you a project I did prior to Gensler. This was in 2006, because it just boggled me why we make glass buildings in the Middle East. And to a certain extent, why we make glass buildings here. You'll see some charts later on that show you the amount of carbon equivalent per meter square in kg that facade materials use, and you'll see glass is at the top of the range. And so this was a competition for KIA, it's Kuwait Investment Authority. They manage some $500 billion of assets, and they wanted a new headquarters. And there were 6 firms that participated, and the whole idea of this was, how do we recreate the central courtyard, which is so important to local life in the Middle East. But how do you take something that's just really 1 story, and how do you get it up to be about 50 stories? So the whole building is broken up into 8-story modules, and each 8-story module has an atrium that kind of looks like this. There's 4 sides that look to the north, 2 sides to the east, 2 to the west, but the north brings in the light. And the rendering on the left-hand side, you can kind of see that there's windows, and we really look to see how can you optimize it. So obviously there's the big glass atriums that are facing to the north, but everywhere else is a window, and there's 10 modules that we did on these facades. This building has 23% glass. The entire facade, 50-story tower, 23% glass. I was very lucky. I know when I was presenting this, and I was much younger and much more nervous at that time, but when I showed that interior rendering, the chairman knew we hit something very important, which is, it's not about just getting all the glass, it's about getting 5 minutes left or left. Okay, very good. Okay. So this is the final project that you can see, and it's the atrium. All the light comes in, only 23% glass. So it is possible. India, where I also see the fascination with glass, it's something that we should really think about. So what we do on some of our projects here is we integrate a lot of technology and looking at materials and studying them. This is just very simply shows you different materials and the kg of carbon or the equivalent that's used on different facade materials. You can see glazing is massive. So we should reduce glazing on the projects that we do and start thinking about other materials as well. Again, this is just showing how curtain walling, especially with aluminum, is massive in terms of the carbon that we are using for that. So one of the ways we do this, and this is just a very quick project I'm going to show, is this project we're currently doing. The building that's highlighted on the red is just one, and there's 3 of these. So first we test this as a glass box to see what is the heat gain going to be, what is the glare, and you can see all these values, what is the luminance is the glare analysis. And then based on that, we started looking at how do we take out glass? And how do we take out glass without affecting areas inside and glazing? So we did this facade, again, ran all the numbers. You can see a lot of reduction already starting to happen when you do this. And then the last thing I'll talk about is biophilia. Let's start incorporating nature into the work that we do. The most soothing experience a human being can have is to walk under trees. And that's why business parks should be by trees and not just in city centers where there's trees, so where there are no trees. So a lot of studies show this. So we look at facades now that start using ceramic frit, that have leaves, that bring in shadows, to give you a sense when you're in an office building that you're still part of nature, and then fins to provide shading to get the sun off of the glass. Very important to look at materials again and do the proper analysis to see what materials are available, what are their footprints, what is the manufacturing capability, et cetera, to make the selections. And so this is the final design that we came up with, and I can't show you the design, it's confidential, but I can just show you that ultimately what we achieved, we went from 914 to about 448, and you can see the other values that have also come down. I think one of the most important ones is glare. Glare, we've gotten from 25 down to 9.2%. When you make all glass buildings, you can't sit next to them, and then you have to buy shades. So it's very important, especially for developers, to this kind of fascination with glass just sort of has to stop, I think. The next point I want to bring up is basements. And people don't really understand this, but subgrade construction requires large amounts of concrete. And a lot of case studies can show that if you don't build and don't go underground and build podiums and go above ground, and I know those have also certain issues with them, but this is something that we can really do, and it makes a lot of sense. So this is worth really considering. The other issue is there's a lot of carbon that gets trapped in our soil, and every time we remove that, that contributes a lot to the energy that we're releasing, the carbon that's being stored, that's being released, and almost 22.5%, it's a pretty staggering number, comes from the earthwork that we do every year on construction sites. So, and then obviously we haven't even talked about the machines that you need for digging and everything. This is just a very quick example where on most of our projects we do study what are the different options, we talk with our clients, we get them to understand the ramifications of what all of these things mean, whether you go into the basements, whether you do podiums, and I'll show you how that design has turned out a little bit later. But that also works with this one, flexibility. We design a lot of buildings for a single purpose, and then we realize at some point when that purpose is no longer needed, we just tear it down. So designing for flexibility is something that you can do, and I'll show you very quickly. This is an office development that we did in UAE, and we helped the client figure out what is the right floor plate size. And the way to figure that out is to look through all these kind of lenses of efficiency, market demand, flexibility. So we went through what are the traditional plate sizes. You can see as you go from left to right that it is about getting plates smaller. The distance getting to about 8 meters from the glass is very important. So we've got traditional efficiency, and that's what everybody thinks about. And yes, the bigger the plate is, the better your efficiency is. And when you look at market demand of what the market is actually using there, can you divide it, can it work? Yes, we can see that's generally okay. So we threw in this twist because it was a great site. So what if you don't need any more office and you got this built? So we started putting in apartment units, and we started looking to see when you've got the bigger plate, the smaller plates where the columns are, what does that do to the location, and what does that do to a typical unit? And you start looking and coming up with this ideal grid, which you see as B and C, where if you took this building down, you don't need office, and you replace it with residential, you come up with a natural 1.5 meter balcony that's around it automatically. So the client was really interested in this, and then we looked at column-free spacing. That is also important in terms of planning. And all of this helped us do a checklist and really help our client to say, yes, C is what we want to go with. And And then when you start looking at the facade, so you can see these sections here, that as an office, we reduced the glass, we put these planters and basically a sill level so that there's no glazing there. But if you look at the diagram to the right, what you can do if you change this into residential, you can take the same unit of glazing and just push it back, and you've created your balcony already. So all the studies in terms of glazing, where you should have glass, another great way of reducing glazing is don't bring the glazing all the way to the floor. It's really ineffective of what it does for you. So we study with all of our consultants what is the optimal location to put glazing, and dealing with, even from now, even though we're designing an office building, can we build in the flexibility so that this can become a residential later? And so this is the project. We're in schematic right now. It's a whole podium base, nothing underground, 5 buildings, offices obviously, but can be very easily converted into residential going into the future. So think about flexibility and think about not digging so much underground is a great way to move ahead. And I guess one of the final things I want to end up with is materials. So we've started something called a GPS, which is our Gensler product sustainability standards. Because we design almost 1 billion square feet of space, we've started to think about how we tackle, in this case, what would be the top 12 commonly used product categories. And the bio-based alternatives are becoming more and more to the market, which is great. We need to learn working with them, bamboo, wood, etc., cork, etc. And really, I don't think we're not going to use aluminum, but the point is, if you can minimize it, it's really something that we should start thinking about. So what we've done, I'm just going to show you a few things as Gensler. Well, we've put together these for our practitioners, and we've just started this. So really, we kind of analyzed, and we looked at 5 areas of impact, 2 levels of performance, 2 regions at the moment, which is really based on America and Europe, but that's going to expand. And 12 of the most highly impact materials that we have right now, and then working with our vendors and engagements. So in our standard, very easy to come down to, on the left-hand side, what is the material, and then you get a dashboard. And then that dashboard starts talking about levels of performance, which we are teaching within our own company to our own designers. There's a standard, Gensler standard, but there's something that's going to push beyond, which is a market differentiator, and that's even higher standards, and that's where we want to go towards. And then areas of impact, obviously, all of these will then get working with representatives. All of the tests and everything is very important so that we have this, and it's very easy to understand what is the right material to apply. And then finally, we are even trying to understand the carbon reduction targets. So as more and more materials and more standards of how we can appreciate what it is that we're specifying for projects can get put into our buildings, this is going to really help us try to make the biggest impact possible. So thank you.
presentations. Our third speaker is Mr. Wu from Loda Group. We look forward to him, listening to him from a developer's perspective. And thank you.
Hello and good evening. So while we had three excellent presentations where the speakers were talking about how to decarbonize on the embodied carbon front, I would like to touch upon the why also, and then we'll go to how. On a lighter note, I would want to ask that how many of you think that your mobile is listening? And when you're talking to a friend, next day you start seeing those ads on your okay. So you are not here just because you saw a thinning polar bear or some forest fire. You are here for some reason, and the fact is that the climate risks have become very apparent. They have been understood now by the ecosystem very well, and there is a lot of forces which are coming together to direct us into this room. So and therefore what I would like to do is to start with the risk angle and why the corporates, why the whole investment community is moving there, and why in fact Adani is also, being such a big company, is venturing on these sides. And then we'll go to the possibilities and the impact of built environment, and then some of the hows which others have also said. So what you see on the slide on the right side is an excerpt of World Economic Forum Global Risk Report. It comes every year, and it tells us that what are the risks that the humanity confronts, both in terms of likelihood and impact. And that one is this year's report excerpt. The green ones are the climate risks, the red ones are social risks. And you will see that as time progresses, most of the risks that the humanity faces are environmental and social. And that is the precise reason that this whole ESG discussion has started all over the place. What I have done on the left side is same report. I have tracked last 15 years, and you will see that what was blue before, around 2008 recession, this blue is basically economic. The whole thing has started to get green and red. So the risks have started moving, the larger risks have started moving on the climate and social side. Therefore, this whole ESG thing, therefore the whole, probably the reason why we are here, why our phones have started bringing those type of videos more and more. So on this slide, we have tried to simplify what some other people had also shown. All human activity, so we are basically a fossil fuel civilization. Anything that we do emits carbon. We live in a house, we take a car to come to this hotel, carbon, energy in the house, carbon, food we eat in the house, carbon. We are sitting in this room, AC is running, it's all carbon. The building is also made of it. So if we continue to do what we had been doing, we take a high carbon scenario. The carbon emissions keep going up, the temperatures also keep going up. And when they keep going up, we confront the physical risks, which is what we were talking about, melting glaciers, changing weather patterns, water stress and so forth. So that's that path. Now what the issue with that path is, and especially for countries like us, which are quite vulnerable, we cannot let that happen. It has huge social costs. I mean, we have huge vulnerable populations. We can't let that happen. And not only us, I mean, the whole world has understood it well. And that's why you see this blue line which is going down, which is that decarbonization line. So here, we all know about Paris Agreement, we all know about various countries having their net zero goals. This line is called the transition risk part. So this is a low carbon economy transition, where the whole world is coming in pushing us to go low carbon. Now this push comes in the form of either a changed regulation. Sir was saying that LC3 code has come. Why it has come? It has come just because of that. BRSR, SEBI has started asking for carbon emissions. It is just because of that. So changed regulations, customer sentiment. A lot of customer sentiment is changing. It is not only those commercial corporate customers, but it is normal residents also who have been thinking and asking about it. The supply chain itself is transforming. So when, say, Adani and Ambuja start offering LC3 and probably cheaper, then why would not people start going in that direction? And then ultimately, obviously, there will be carbon costs and there will be rising energy costs. So both are risks. So if we don't prepare ourselves and we design the whole thing and the customer comes and asks something else, or if a regulation comes and asks something else, they say that now it will be mandatory to put as you were saying, a carbon passport of that building, then the stock that we are putting out in the market actually loses its importance. So it's very important to stay ahead of that curve. So in our case, we want to stay ahead of this curve and tackle this transition risk. Similarly, tackle that physical risk. And therefore, at Lodha, our sustainability strategy rests on those two pillars of resilience and decarbonization. The issue is that you decarbonize or you don't decarbonize. Both are risks. It's a very fantastic thing. Both sides of the coin are risks. They bring with them huge social costs and they delimit growth. Whereas when you take the path of resilience and decarbonization, you are actually doing, as we saw in an earlier presentation also, nation building and ensuring that those people who are more vulnerable don't get affected. It's a just transition. And at the same time, we can sustain growth and maybe become a global leader in terms of supplying these new age materials. I'll not go on resilience because this is mainly on decarbonization, but maybe 10 seconds. So we have started using global climate models then on IPCC scenarios to generate synthetic weather data which can be used in infrastructure design. Because that's all designs have been done on historic data, and historic data is no longer representative of the future, so that doesn't work. So let's scientifically find the numbers which we should use in our designs. So that's one thing we're doing there. I'll not go there. On decarbonization, we have formed something called Lodha Net Zero Urban Accelerator in partnership with RMI. What it does is, it has 5 focus areas which look at the entire emission spectrum of the built environment. Now, why built environment? Because in multiple slides we have seen that 40% of the overall emissions come from built environment. But the overall impact of built environment is even larger. When we talk about transportation, half of it is commute. So it's the stance that we have taken is that we are not using building as the least count. We are using that city scale or the whole urban realm as the least count, a neighborhood as the least count. So if you are able to live in an efficient house, if you are able to maybe walk to your work location and you have an efficient office, so that's the solution that we are seeking. 20% of energy in buildings, it's all built environment. Half of transportation is built environment. 1/3 of industry is steel, concrete, cement, other building materials, aluminium, glass, and all. Land use is again changed because of the built environment. Most of the waste is being generated in the built environment. So built environment is a canvas where the whole humanity is painting that whole thing. And the opportunity that we have in this room, so a developer is here, an architect is here, the engineer is here, maybe some material suppliers are here, so the whole ecosystem is here. And what we need is all of us to come together to find that solution. Subsequent slides will also show that, but one of the major issues that we have confronted in our decarbonization journey is lack of confidence in using newer products. Most of the civil engineers, construction people, they still want to be conservative because it's not like unlike any other product, a building is a product that is going to last a lifetime or even longer. So we can't play around with that. We need to be very safe with that approach. One of the problems that we have seen is that there is huge data scarcity. Nobody knows. You start referring to some databases which are not representative, and when you dig deep, you find that the numbers are different. So I think the need of the hour is that we come together, we create these solutions, we showcase them to build confidence, and then change the entire ecosystem. It's doubly important for us because if you look at other world powers, they got a chance to grow when the climate risks were not apparent. But we are uniquely placed in a position where we have a once in a lifetime opportunity to grow, and that is exactly happening when the climate risks are all apparent. So, instead of passing the buck, probably we can act responsibly and show to them that how we can decouple growth from emissions. These numbers that are shown on the slide are actually very misleading. Everybody shows them, they are very misleading. They say that the urban population in the country will double, 600 million. There was another slide showing 590 million. Almost the amount of building stock that is available today will be built again, in next decade or so. The number of cities with more than 1 million population in the country will double. So currently in Europe you have only 35 such cities. In India, more than 1 million population cities. By the end of this decade will be 70. But these numbers don't actually reflect the reality. Just 2 weeks back, our MD was on an interview on a TV channel. He told that the total number of homes that the urban centers in India will sell this year, which is one of the best years so far, will be close to 5 to 6 lakhs. Whereas China, which is now same population, having a bad year, they will be selling 1.1 crore homes this year. 5 lakh of ours, 1.1 crore of theirs. In their best of their times, they sold 1.8 crore homes. So the point is not that how much China is bigger than us. The point is that this is going to happen in India. As India grows, India will be buying 1 crore homes. So it's not that we should not be confused by that 2x. We should look at the 20x. So it becomes very clear that we must transform India's built environment because without that, it is not possible to achieve the reduction in GDP intensity by 45% by the end of this decade. So what we have done at the accelerator is that we have actually broken down the carbon emissions of the built environment. We have uniquely brought in the transportation angle also, and we are identifying initiatives across these areas, which is embodied carbon, reduced energy demand through passive designs and equipment efficiency, then renewable energy transition, and then obviously green mobility. So what we do in each of these boxes together is the net zero trajectory. So everything will have to be squeezed out. The issue with embodied carbon is, unlike operational carbon, and very rightly shown by Abhijit also, that as the grid continues to become greener, as the equipment efficiencies continue to improve, the operational carbon will continue to shrink. Whereas embodied carbon does not have that opportunity because it is locked in at the beginning itself. Unlike equipment which can be retrofitted. Embodied carbon has no retrofit. It is built once, it remains forever. So somebody can put wrong ACs in a building and still, get away with it. But when you are building a high carbon intensity building, there is no way. So it's very important. So these are the general strategies which everyone covered. Don't build when it is not needed, and build with that reusability in mind. We have also been thinking about how can ultimately our MLCPs will start working as something else. Build with less resource efficient designs. Use materials with low carbon intensity. Your recycled steel, your greener concrete mixes. Promote usage of alternative materials. Now this is very difficult because a lot of people in the room themselves would not be very keen to use them. So it's important to create those pilots which generate confidence. Procure locally, so that was again covered already. Limit wastes. Now then, we also have some materials that are capturing carbon, and in fact that was also covered. And then share the learning in the larger ecosystem. So it was all covered. So what we did, we started with a baselining exercise. And this baselining exercise is actually available on our website. So you go there, you can find our baselining exercise, you'll see how we arrived at this. This is 80% of our portfolio, roughly 400 kg per square meter, roughly. Now, when we were using this, when we were developing this template, Dr. Prasad very rightly said that we will not only use the databases. Let's try to capture the real data. And when we started talking to our supply chain, we realized that there is no data. There is very little data. You really have to push them to get the data. So that was the primary problem. Then obviously, 2 times I've already said confidence on the low carbon materials. And because of that lack of confidence, there is lack of market demand. And therefore, lack of scalability. Then obviously, the companies, it's very good that I saw that your LC3 is coming out from your side. I really want to know what is the LC3 delivery roadmaps from all the cement manufacturers. So again, this is very much what others have also covered. So baselining, working with the supply chain to get the data. While the cement and some steel companies, aluminum manufacturers, they might come out with the data, but say the extruder, say the assembler, say the blockwork manufacturers, say those other parts of the supply chain who do not have that data out, we need to work with them to enable them to actually bring that data out and bring it all together for everyone. So we have been contacted by a lot of startups. They claim to have low carbon products, but when we evaluate, we realize that they are not fit yet. So it's important for us, practitioners, architects, structural engineers, to work with them on those pilots to help them co-create a viable solution. So that is something that can be a takeaway for all of you. Just whoever client you are working, push them, let's try to do this and see how it pans out. And then on certain aspects, we can all together influence the policy also, that if there are right market signals, the policy can also evolve for us. This is something that I have covered already. One of the primary things that we are trying to do apart from that whole baselining exercise is to do pilots. We are quite open on anything that is being proposed, and the idea is to learn from those field tests to understand how they perform. It could be blockwork, it could be another type of cement, it could be some alternate for the steel and so forth. Even 3D printing or even anything that increases the durability of the building. also, in this process, we are quite specifically talking to our supply chain. A lot of people already, I mean, I don't know whether our supply chain partners are here or not. We are partnering with the startup accelerator where a lot of climate tech technologies are incubated. We have requested them that if they can be field tested at Lodha Net Zero Urban Accelerator at Palava. And then obviously, while everyone covered this also, construction waste is a very, very serious issue. What's on paper versus what actually is, you know, it needs to move very much in that direction. I will not take any more time. You all are the other esteemed speakers have already covered those things. So thank you. Thanks a lot.
Thank you, and that was very, very interesting. And it's great to see that developers are right on track for sustainability ambitions. And you made a very important, identified a very important fact, global fact, that the amount of construction that's going to happen in India is just phenomenal. I think it's for the next 20, 30 years. And there's an opportunity for all the stakeholders to leapfrog what's happening in the rest of the world, the mistakes that are made to rectify leapfrog technology. So thank you very much. Great. Well, our last esteemed speaker, Mr. Vijay, and I look forward to your presentation because obviously Vijay has spanned the whole spectrum. I mean, concrete is concrete, it hasn't changed, but it has. You know, concrete, I remember when I was studying, was 20, 30 megapascals, and now I know that in Australia they're testing 220 megapascals, half the strength of steel, and now it's the biggest culprit for carbon neutrality, but there's talk of carbon zero concrete, which I'd love to talk to you, Nash and Vijay, over dinner. So there's a lot happening, and there's a lot happened over Mr. Vijay's career, and so I look forward to what he has to say.
Yeah, good evening, ladies and gentlemen. I am the last speaker now. I will try to finish as per the time schedule, certainly. I'm going to speak on what are the potential avenues for reduction of carbon. So I start with the climate vulnerability. I think what Anil has been talking, I'll just substantiate it with the Indian data. I think what we know that the United Nations has estimated that the top 10 disaster-prone countries, I think India happens to be the third largest country which experienced disasters. The financial estimate done by State Bank of India says that we have lost 6% of GDP. And what McKinsey reports shows that it is going to increase fourfold by 2050. Some researchers have recently done a study and found out that how much is the vulnerability map of India indicate. And it shows that almost 80% of the Indian population lives in districts which are highly vulnerable to hydromet disasters. Whatever I am talking here has some reference. I am standing on the shoulder of big organizations and many people who have done a lot of research. So, coming to concrete. First, good thing about concrete. Yes, concrete is the versatile material, as he has said that we are producing something like 4.1 billion tons of cement, converting to around 15 billion cubic meter of concrete worldwide, and it is increasing. So why? Because concrete is locally available, it has the adequate engineering property, the properties that any structural engineer desire, they are available today. Whether it is composite strength, tensile strength, one-stop elasticity, you desire anything. And not only that, from M20, it has gone to, as he has said, to we have changed to high strength, high performance concrete, and now we are transferring ourselves to ultra high performance fiber reinforced concrete, which is minimum strength is 150 MPa. So totally different material, but basically concrete. So and the most important thing is it has a low cost, environmental friendly. Yes, I say concrete is environmental friendly. I have the data. This is from NRMCA, which shows that concrete amongst the various building materials has the lowest energy consumption. It yields no byproduct, but it has the fantastic capacity to absorb the waste product of the other industry, be it thermal power plant, fly ash, or slag from steel industry. So this is the scenario, but the main problem is cement. And this is what the report says from the McKinsey, that 7% cement. And what is more concerning is about, if you see the kg CO2 per dollar, it is more concerning. And that is why the Global Alliance of Building and Construction says that you need to reduce 3% emission every year. Now India's contribution to global scenario, I must say that our country has submitted one report recently to the United Nations framework on climate change, and it has very clearly pointed out that we are just producing 4% of the total carbon emission in the world. We are sustaining 17% of the population and 24%. So, and our per capita consumption is 1/3 of the global average. So, carbon emission is not our baby. And if you see the global picture, idam na mama, it's not our baby. So, the global picture is also that the champagne glass of global inequality. I don't want to go further. India's cement production, I think it is today at around 300 in 2020. Installed capacity about 537. And the current share of Indian population, India's cement sector is around 5.63%. Now we are producing around 340 million ton, and the global per capita consumption is much lesser than the global average. We have a lot of things to go. We can increase because we have to develop, and cement is the essential material required for development. These are the different types of, the cements that we produce. The major share, as you can see, is blended cement, 65%. And this is the CO2 emissions that is happening. It's not the global warming potential. Now, if you peep into the future, we have the data that 70 million people are going to be added to the urban scenario. This is going to happen in the next 20 years. and it is our responsibility. So they are going to come to urban area, we can't help it. So we have to provide them accommodation. So there is no other way but to go vertical. We have no other way. We have to. So housing requirement, I think Umesh has shown this figure. But see how much it goes into some very mind-boggling figure. We have to construct something like 1500 million meters square per year. In the next 20 years per year, it's a very big figure. If 270 million people come here. So, one estimate, from 340 million tons of cement, we need to go to 660. This is the estimate by Center for Science and Environment, which has been verified by their expert. So 660 million, double, more than double. So the first question that comes to my mind is whether we have the material for concrete making. Concern. Coarse aggregate, our leads are increasing. And in the Indo-Gangetic plain, the leads are much more. River sand, vanishing resource. Crushed stone sand, the resistance to use. And then recycled aggregate concrete, we are producing a huge quantity. The estimate is something like 530 million to 750 million tons per year, and only 1% is used. Only 1%. Now, even in the recycled aggregate concrete, leave apart that, even in construction-related waste of concrete, there is no data. One very good thing has happened is from Godrej Construction. I must, congratulate them for doing this study. Foot on the, they just went to 14 sites of Godrej Construction and Mahendra Lifestyle, and found out that this is the waste that is created on a concrete construction. Now, if you see that it is 1 million square feet of construction requiring around 1 lakh cubic meter of concrete, the waste is something like less than 1%. The cost of which is around 60 to 70 lakhs. So why not establish a recycling plant and a filter press and recover everything? It can be covered. So now when you are ordering concrete, it is your responsibility because it is a circular economy, and you also have to see what your stakeholders are also doing. So this is a must. Cement, I think he has mentioned that very less limestone is available. So what is the option for us? LC3? He is laughing. So it is going to take time. It is not going to happen immediately. So we have to go to the areas of forest and congested area to extract limestone, which is going to increase the cost. So we have large amount of waste material, and more of such material will be needed. Water already has been described. So now, before I go, what are the levers in which we can reduce? I think I must take the help of Girish and his team, who has done work for me and supported by Global Cement and Concrete Association. So what we have done is a comparative assessment of a tall building. This is a tall building, G plus 40. Typically, what you can see here is that something like 31,000 square meter of area is available here, and 12 flats per floor, and I think the alternatives that we consider. We have considered that it could be having RC frame structures and shear walls. Then we also thought about using different types of partition wall, My1 system, non-structural wall, or AAC block. Then we thought that we can also introduce some variation in the grades of the concrete, say different grades, and then we have selected that the different kind of cementitious alternative, like OPC plus fly ash, OPC plus GGBS, and wherever necessary, you add microsilica. So we have 12 alternatives to consider, and plaster also we have considered like this. So this is the typical structural system for My1. This is M50 to M80, and the other alternative is M60 to M40. This is the typical, the floor plan and the load combination that you considered in your structural design. And then alternative My1 system, we have used the software, ETAB and SEP, although I think this is what Dravid's team has done. It's not my job, but yes, they have ensured that all the codal requirements are satisfied in all the alternatives that we considered. And this is the final result that we got. Now we have used different varieties of concrete. Now what we have done is we have considered only the commercial concrete that is available from a ready-mix concrete part. We are not considering here any other thing. And we have considered the global warming factors from the International Finance Commission data, because that's the only thing available in 2017. So we are using that. So this is for 50% replacement of GGBS, and then we have also considered fly ash, generally around 20 to 25%. And this is the mixed design for M60, 70. And finally, I think the picture comes, we have found out a summary of the carbon footprint, and also we have found out the cost of the lowest alternative. And then finally, this is the picture that emerges, that the shear wall alternative with having the AC block has the lowest carbon. I think our carbon assessment goes from 272 kg per CO2 to 382. But the lower values we got in the AC block wall. And suddenly I think you can see that My1 also came into being if you consider the cost. But more or less I think the cost and carbon, the lowest carbon matches more or less with the lowest cost. This is the conclusion. Secondly, we found that there is no point in going for a higher grade. This is a revelation to us, that it's not necessary to go for higher grades of M70, 80. Maybe for this kind of alternative, maybe M60 is better. And then amongst all the alternatives, the first 5 alternatives were with OPC plus GGBS. Obvious reason, because we done the 50% replacement. Now coming to the next step, what are the things that we do to reduce the embodied carbon? What is available? I think the guidance is available from UK, Concrete Center, or the NRMCA from USA, and this is from our Global Cement and Concrete Association, which has said that, okay, cement, they are already doing carbon capture, they are talking, a lot of work is being done, but really speaking, nothing at the moment. We can't depend on that. So we have to go to concrete to reduce something in cement. There is no alternative. So what are the alternatives? I think somebody has said that foundation is a major thing. So we tried it, and this is a M30 concrete. The alternative available is to go to replacement level, maximum possible 70% GGBS. The developer happy. He said 120, this is a building in Ahmedabad, 120 cement OPC, how can you achieve 35? So we provided the maturity census to them and found out that, okay, no problem, these are the values you got, actually speaking. So 70% replacement worked very well. Another alternative, and I think the amount of reduction of carbon footprint I have calculated, something like 84 kg per CO2. Other alternative is to depend on the 56 day strength instead of 28 day strength, and I have found one structural engineer who could use it in his shear wall in Mumbai. And we have found that the structure that he is using is prone to thermal problems, so we have used high volume fly ash concrete and possibly permitted us to use it for the shear wall, a bold step I would say. And this is the temperature gradient. You can see maximum temperature not going above 70 degrees and the temperature differential between 20 degrees centigrade. So this is one alternative over. Next is mix optimization. Typically what we see here in Mumbai is this, that excess cement is being used by the ready mixer. Everybody wants to have his, margin. Results in higher cement. Optimization is essential. This is what we have done, reducing cement. But then, if you have to do it, we need to have quality system in India. I done this for when I was looking after the ready-mix industry. First time introduced a regulatory system on quality through Qualicon, the Quality Council of India, and this is essential. I think you should consider this because you are not going to the plant. Neither your representative is able to go to the plant. Somebody has to go. Somebody has to go there. So necessarily you must get some assurance about the quality. So much obsession is happening about compressive strength, and this has resulted in terrible problem. For example, if anybody is using anything, you are just concerned about compressive strength, but what happens to other properties? Yeah. For example, modulus of elasticity for M60, and this is a data which I collected. Modulus of elasticity, can you afford to have, that is why the code on 16700 says that modulus of elasticity need to be calculated, not calculated. It has to be estimated actually of the material that we use. The cost saving coming out of QAQC, and this is not my data, this is from United States. Unfortunately, we don't have created such data, but for a developer, this must be essential. That he is able to, if he is able to achieve quality, then he is able to reduce the standard deviation and the coefficient of variation in concrete, which results in huge saving to him. Concrete durability, when I was president of IC, I created this document, and still I think very few people are following. What is being followed today is just the pre-qualification of the mix for durability at the most. Even that is not followed. We suggested this sampling frequency, we suggested this conformity criteria, and we suggested the acceptance criteria also. People need to follow durability because durability ultimately means that you are exceeding the life of the structure, which means that you are saving material. So, performance-based specification is the only answer, in my opinion, as far as concrete construction is concerned. Wherever we are using concrete, we should have performance-based specifications for strength, for durability, for anything that you need. You can have, and these are the salient features of performance-based specification. And it can also help you in reducing, because you can specify that, okay, this is the benchmark, you should have carbon emission of concrete up to this level. This is possible, but this is not possible in the prescriptive specification that is being today followed. So we have to change from prescriptive performance-based specification. So this is the this is a codal requirement from Canada, which is already available. What is the responsibility of the owner, contractor, and the producer? Now, last, I think, before I conclude, I have two interesting slides where I am not a researcher, but I just got involved into this research. Anil was talking about zero cement, zero emission cement. I think I have an opportunity to work with a cement producer who is just using 5% clinker in his cement and 40 concrete. This is from JSW. And I have made a compare. I have M40 concrete made with 5% clinker. No problem as far as strength is concerned. I have tested durability also. All the parameters, water permeability test, RCPT or the rapid chloride migration, fantastic value. 8,000 kilometers of coastal highway, coastal area India is facing, one of the best alternative coming from a cement manufacturer himself. So zero cement. Second alternative is bio-based. I think how many people have today heard about this concept of biochar? Have you heard about it? This is a biomaterial produced through thermal conversion of biomass under a limited supply of carbon, and the advantages are fantastic. So increased surface area and porosity, large sequestration of CO2 is possible. Can help in maintaining humidity in a room. We are today, as an architect or is concerned about the quality of the air in the room, humidity level. It can become a low carbon sink as far as the IPCC report is concerned. I had the opportunity to test it, unique opportunity I would say, and a startup came to me and he said that he is producing a biochar based on the pyrolysis process based on cashew nut shell somewhere in south. So I tested the material, surface area I found that surface area is 10 times more than that of cement. The porosity is something, it is going into nano level or even below that. So this is the pore diameter, water absorption very high, but at the same time desorption is also very high. So we tried to make bricks from this. We could make bricks, but we need Laurie Baker to accept this because of the color. So, but then we also tried to make green panels, and we found that we can push around 6% of, we can replace 6% of sand without other operations. So carbon sequestration is possible for a cement sector with the use of such material. Last slide, conclusion. I think I agree with Abhijit that there is for every project we need to evaluate alternative wherever we are and find out the carbon content. And for that purpose, it should be made, I think it should be almost made compulsory. Now it's urgent need to create a national benchmark. He was talking about Bureau Point benchmark. I am suggesting we should create national benchmark for different tall building, maybe bridges, maybe different structures. We should create that, so that ultimately we know where we stand. And from there we can come down systematically to zero sum. Today we don't have any benchmark. Where is the benchmark? So we have to create that benchmark. There is no data on global warming potential at the moment. We just are relying on the work done by IRC 2017. He agrees with me. So somebody has to come forward, and it is the responsibility of the producer to find out, to help us in getting the global warming potential data. Use the possible levers, whatever is possible, to reduce cement and cement content, and in concrete, adopt performance-based specifications, and use innovative material and techniques for carbon reduction. I think, thank you for kind attention. I was just given time.
Thank you very much. Who says lecture on concrete's boring? That was fantastic. Well, one thing I've learned is that we as an industry, as professionals, we can do the impossible if we think collectively. And that's the message that I've heard today. Thanks. So we want to keep on time, so I've got 5 minutes of Q&A. And I've got plenty of time to talk and ask questions over drinks and dinner. But I'll leave it to the audience if there are any burning questions that you'd like to ask any of our speakers. We have got 5 minutes. Questions? Anyone? Over there.
Good evening, everyone. I'm just going to make 2 statements over here. The first statement, it comes from Reuters. Very recently, in Europe, most of the banks and the financial institutions are involved in greenwashing, means reporting incorrect data about the ESG initiatives taken by various stakeholders. The second statement comes from our Chief Economic Advisor, Government of India. He says that there is absolutely no doubt that the climate change is an important aspect, but for a country like us, we cannot sacrifice growth. So these are 2 extreme statements, one coming from the developed countries where cheating is happening, and on the other side, the Chief Economic Advisor to the Government of India is making such type of statement. So what should be our stand as professionals when we talk India as a country chasing the ESG goals or the decarbonization in building industry? So if anybody can attempt this question, I would be very happy.
I think I would try my best as far as possible. I think nobody can dispute that India is a developing country and we need economic growth. There is no other way we can think about it, because we have to uplift our own population. So we can't compromise on that. And the government of India has already been taking steps in terms of changing from coal-based to renewable energy. Huge efforts have been made. But no, today the advanced countries should not lecture us saying that you stop your thermal power plant, because we need our energy for our growth. We can't do this. We have to find our own path. We agree to the final scenario that, as I already said, we are not created this problem. The West should give us some money. Am I correct? $100 billion fund is already available. How much we should get? Yes?
You, in fact, it is from his slide only which I attended in Ahmedabad when he came. That when we talk about carbon footprint, we are number 3. Number 1 is still developed country like China or US, because they are producing more operational carbon. Embodied carbon may be less because we are a developing country, but ultimately I think your slide showed there when वहाँ पे हो गया है तो बात अलग है, but operational carbon is still they are producing more.
I hope that answered your question. Just over there.
Good evening, everybody. So basically, we all are talking of embodied carbon, but that is capturing only the initial part. But I can see all over Mumbai or all over everywhere. After every 20 years, 30 years, the buildings are going to repairs, restorations, retrofittings to increase the life and all that. So I feel whatever criteria are being set for hello, am I audible? Okay. So I will request you, whatever criteria are being put forth, they should consider the lifespan of the structure, and that should be, the selection should be done accordingly, and then that carbon embodied carbon should be looked at.
Yeah, so I don't know whether I can take the slides here, but there is an entire framework of life cycle of building. Where embodied carbon hits hard is where that cradle to gate or cradle to practical completion. But there is cradle to cradle calculation where you would have roughly about 25% of additional embodied carbon beyond your practical completion. So even if you target 75% of it between practical completion, from cradle to practical completion, you are still hitting a major component of embodied carbon. So it is there. There's a way to calculate it, and calculations are pretty simple, as I said. But every stage you need to look at what is embodied carbon for that particular material at that stage, and you work out. Now, another option looking at it: do we really require to design for 50 years design life? A lot of buildings have designed for 100 years design life, and the addition is only little delta, but you can have that extra 50 years. A lot of consultants consider that, a lot of clients consider that, especially the important buildings like hospitals and others. And we are designing a hospital in Navi Mumbai. And one of the questions we asked to the client saying, is it 50 years or 100 years? He doesn't have idea about embodied carbon and all this. He says, if I'm putting in this much money, I'm not going to demolish in 50 years. That's a mindset. And that helps for everybody to work towards whatever 50 years or 100 years. But yes, the embodied carbon calculation is from lifestyle, LCA they call it. Hope I answered your question.
Thank you, Abhijit. Well, I'm going to call it quits there. We're only overdue by 1 minute. Pretty. Okay, next. So just to conclude, I'd like to call up on my partner, the co-curator, the other person that
So without Anil, this would not have been possible. So I'll start with thanking Anil first. And then of course thank you the sponsors who have been kind enough to make this show happen, and the guests who have invested good time with us into this. I hope you take good memories of this back. Okay? Thank you.
Hello everyone. I would like to call upon stage Chairman of CTBUH India, Ravi sir, to felicitate our speakers for tonight. Can I have invite sir on stage, please.
Is this like man of the match? I've always been.
Can I call upon stage Abhijit Kulkarni? Can I call upon stage Abdullah sir? Can I please have on stage Vijay Kulkarni sir? And we also have our moderators for tonight, Anilira sir. A little token of appreciation.
Okay.
Can I also call upon Nikhil Sanghvi sir? Thank you everyone for attending today's seminar. We can proceed to the other.
Thank you. Just before I want to make some key message that while going to which memory, one spirit memento we have been from Adani, you can take from the ballroom number 5. Thank you very much.